So for problem number 11, they want us to verify that f of x and g of x are inverses of each other's. So the only way that that can happen is if I compare fog and goff to each other. So starting with fog, I'm going to say, okay, I see that I have x squared minus 5, and then I'm going to put g inside of it. So that means I'm going to take g and put in the square root of x plus 5. Now, taking a look at this, remember that square and square root are inverse operations of each other. So this square and this square root are going to cancel out. And that's going to leave me with x plus 5 minus 5. Well, plus 5 and minus 5 are inverse operations. So those are going to cancel out, and we're just left with x. So fog is equal to x, so that checks out. The next thing I need to do is I need to look at goff. So taking a look at goff means start with g. So g says the square root of x plus 5. Make sure my plus 5 is inside that square root. And now it's saying, oh, I need to do x squared minus 5 inside of that. So x squared minus 5. So let me square. I'm just going to erase that and make that a little bit bigger here. And now that I've made it a little bit bigger, x squared minus 5. Okay, so now, writing this in a more formal mathematical way, big square root, the box is going to be a parenthesis set, an x squared minus 5 plus 5. Well, I don't need this parenthesis set here because there's really nothing in front of it, and it's an addition right after it. So if I just rewrite this, I'll see that it turns into the square root of x squared minus 5 plus 5. And then again, because minus 5 and plus 5 are inverse operations, they'd cross out, leaving me with just the square root of x squared, and I know that square and square root are inverse operations, so they cross out. So this whole thing is just going to turn into x, which means that goff is also equal to x, which checks out. So because fog is equal to x and goff is equal to x, these are indeed inverses of each other.